Let us go to exercise 1.2. The first question, we have to prove that root 5 is an irrational number. So first of all, we will assume that root 5 is a rational number, okay? If it is a rational number, it can be put it in the form of a by b, while a and b are not equal to 0. If now when I square on both the sides, we get root 5 whole square will be 5, which is equal to a square by b square. So from this, I get what is a square. A square can be written as 5 into b square or 5b square. So it means that if a square is divisible by 5, then a is also divisible by 5. That is what I have given here, okay? Now in case, let me consider some other integer c, okay? If a is equal to 5c, and substituting a is equal to 5c in this, what do I get? 5b square is equal to 5c the whole square, which is equal to 5b square equals 25c square. Then b square is equal to 25c square divided by 5. So this 5 moves to RHS and it gets divided. So therefore b square is equal to 5c square. So which means what? B square is divisible by 5, which implies that b is also divisible by 5. Correct? So therefore, we have shown that a and b are divisible by 5. That is, they have common factor 5. Contradicting a and b are co-prime. And also, it contradicts that root 5 is a rational number. Therefore, we can conclude that root 5 is an irrational number. Let us solve the second question of exercise 1.2. It says we have to prove that 3 plus 2 root 5 is an irrational number. So when we consider it to be a rational number, okay, 3 plus 2 root 5 is equal to a by b, where a and b are not equal to 0. Then I'll have to isolate the irrational number. So here 2 root 5, I've written in LHS and I'll shift 3 to the other side. So it becomes a by b minus 3. Then I need only this root 5, right? Only irrational. So therefore I get it as root 5 is equal to, when I take LCM in RHS, it will be a minus 3b by b. Then shifting this 2 to RHS, we get root 5 is equal to a minus 3b divided by 2b. So therefore, a and b are the integers, while a minus 3b divided by 2b is a rational number. But root 5 is a rational number, right? So meaning these two are not equal. Correct, no? So therefore, it contradicts the fact that root 5 is a rational number. Therefore, we can conclude that 3 plus 2 root 5 is an irrational number. Let us solve third main first question of exercise 1/2 real numbers. So we have to prove that 1 by root 2 is an irrational number, okay? So assuming that 1 by root 2 is a rational number, we get 1 by root 2 is equal to a by b, while a and b are not equal to 0. Now, from this, I'll have to get only root 2, the irrational one side and the rational number on the other side, okay? So when I cross multiply, what do I get? I'll get root 2a here in RHS, and this b into 1 is b. Understood this step, right? So now root 2 is equal to b by a. I shift this a to the LHS, right? So now since a and b are integers, it says that this b by a is rational. Yes, b by a is the rational. But it implies that root 2 is also a rational number. Okay, but this is irrational, this is a rational, right? So therefore this contradicts. So therefore this contradicts that 1 by root 2 is a rational number. Therefore we can conclude that 1 by root 2 is an irrational number. Let us solve the second question of the third main exercise 1.2 real numbers. So it says we have to prove that 7 root 5 is an irrational number. So assuming that 7 root 5 is a rational number, 7 root 5 is equal to a by b. So now what do we do? We will segregate the irrational and the rational number. So I'll isolate this irrational number. I'll retain it in my LHS. So shifting this 7 to RHS, I'll get 7a by 7b. Right. So now here if you could see a and b are integers, right? So which means that a by 7b is a rational number. And it says this rational number a by 7b is equal to root 5. But root 5 is a rational number. Right? Therefore, it contradicts the fact that root 5 is a rational number, and therefore we can conclude that 7 root 5 is an irrational number. Let us solve the last question of exercise 1.2 third main real numbers. Okay. So it says we have to prove that 6 plus root 2 is an irrational number. So 6 plus root 2 is equal to a by b. When we assume it to be a rational number, then segregating or isolating this irrational number, we get root 2 is equal to a by v, this plus 6. When I shift to the other side, it becomes minus 6. So then root 2 will be equal to, when I take LCM in the RHS, it becomes a minus 6b divided by, since a and b are integers, a minus 6b by b is a rational number. So it says that this rational number is equal to this root 2, which is an irrational number. So therefore this contradicts the fact that root 2 is a rational number, and therefore we can conclude that 6 plus root 2 is an irrational number.